So, let us go for the another application like an esterification influenced by the adjacent group. How it is going on, let us see. A benzene containing a COOH, a carboxylic acid group, this is COOH, when treated with ethyl alcohol, the CH3CH2OH, the OH of this one and the OH of this one reacts, and one O will be left over in the center and one water is dropped. So, the acid and alcohol react with the help of a catalyst like concentrated sulfuric acid is one of the reagent that drags out the water from these two compounds. And however, in the center you have one oxygen, C double bond with this oxygen. Sometimes OH from that side or from OH from this side. So, one side OH, the other side hydrogen, net is water dropped out and the ethyl group will be as it is. So, this is called what? An ester is formed. So, therefore, it is called esterification reaction, a fair reaction between acid and alcohol catalyzed by the acidic medium. So, ester is formed. But the same reaction when you want to do with a same benzoic acid, same conditions, but both the sides we have some methyl groups. Now, this methyl groups are blocking both the side. So, the same ethyl alcohol is added here also, but unfortunately the reaction is not taking place. The reason explained, the COOH both the sides methyl groups are blocking. If the methyls are found to be at para position or at meta position, there is no much influence, but specifically at ortho position we have this problem. And this is also extended to study what is the result. Instead of the COOH, we have taken now like this, right? The COOH, the length of the COOH is increased now like this. Out of the curiosity of the scientists, it is studied. The COOH, instead of COOH, CH2COOH. Then the blocking is up to only this area. So, the COOH is above the area. So, therefore, once again the same reaction, if you do it, the reaction taking place. If this methyl size is increased, again ethyl and ethyl, reaction is again found to be less. When this is increased, the reaction taking place. When the side group size is increased, the reaction is decreasing. So, like that, a series of experiment clearly shows that it is not the nature of the alcohol of the acid, but it is the size of these side by groups. The bigger the size, they are covering the CO, that is covering is nothing but the sterically the approachability of the alcohol to the acid is not possible, therefore, the reaction is failing. So, it is clearly showing that the spatial that is space requirement, if it is fulfilled, the reaction takes place. Otherwise, there is a space problem is there, whether you like it or not. The compound is more reactive or less reactive. The spatially the reaction should takes place, means the spatially the availability of the space should be there, otherwise the reaction will not take place.